In the last video, I introduced this seemingly simple but very useful model of the function of a muscle, in which we have the muscle fibers oriented like this. They have some length, and maybe they're moving at some velocity, and they're attached to tendons. Got the origin up here, the internal part of the tendon and the external part of the tendon here, and down going off this way is wherever that tendon inserts to. And we saw that we could think of this as sliding back and forth. So this part sliding this way or sliding back that way. And to close out the week, I wanted to talk about how this model of muscle is manifest in some of the muscles that we might be familiar with. And we can divide this up into different types of muscles, or different types of pennation of muscles. Pennation referring to the angle right here, the pennation angle. So I'm just going to go through a few muscles that probably you're familiar with, or hopefully you're familiar with, and talk about what their fiber orientation looks like relative to their internal external tendons. So first off, I want to talk about a type of muscle called parallel fibered. Parallel fibered muscle. Some people call this fusiform, but I don't. Occasionally you'll hear the word fusiform, but probably not from me. So a good example of this is the Sartorius. So the Sartorius goes from up here and it wraps all the way around your leg like this and inserts on the medial side of the knee. So it acts as an adductor of the hip. So when it contracts, it's going to pull the leg in like this and also probably internally rotate it by some amount. Now, what does that muscle look like? Well, its origin looks like this, and its insertion, well, way down here, and its muscle fibers are oriented like this. It has a pennation angle of 0 degrees. So it's like this angle here is 0 degrees. You can imagine these muscle fibers just being completely straight, and hence the name, right? Parallel fibered muscle. No surprise. A different case comes from a muscle like the EDL, Extensor Digitorum Longus. Now that is a muscle whose tendons go like this, but then it runs up the side of your leg like here, and it attaches on the fibula like in here. So the EDL is a great example of a muscle that's called unipennate. And by the way, I won't be asking you to memorize what type of pennation specific muscles have, but I will be asking you to know what the difference between, say, a parallel fibered and a unipennate muscle is. And the unipennate muscle is exactly what I drew up earlier. So we could imagine the tendon down here. It would come up like this, and then you've got the origin up here. And you can almost see how it happens. Like the muscle fiber is going off like this. This is like almost like to the exactly what to the point what I drew up. Up above. This is unipennate, only one way of pennating. Two more sophisticated types of muscles are bipennate muscles and multipennate muscles. So an example of a bipennate muscle is the rectus femoris, which is right here. It's like a big, strong quadricep muscle. So let's write out bipennate. You might have a guess as to where this is going. We talked about unipennate muscles, uni for 1, bi for 2. well, you can probably guess what this is going to look like. Got a thing that comes up like this, and then something like that, and then we're just going to go off in two different directions. So it's almost like two different unipennate muscles going off in different directions. And then sometimes you get like some business like this, where they kind of break our little nice model. And then, as you might also guess, you can go from bipennate to something called multipennate. Which maybe the best example of this is the deltoids up here, which if you know what those look like, you know they have these multiple different bodies going off at different angles. And so the internal tendon of that muscle kind of fans out like this, and then off from each of them, you have like pennation going off like this, and 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 this, and this, and this. And it forms this, kind of bundle of muscle like this. And next week we'll talk about what some of the advantages and disadvantages of these different types of muscle fiber orientations are. But the nice thing is that we can always, no matter how complicated this gets, we can always break these down into individual unipennate muscles. And we can even think about the special case of a parallel fibered muscle being a unipennate muscle with a pennation angle, which is that angle right there, of 0 degrees. So something that we quite often will do is let's suppose we were interested in the what's a complex muscle, the pectoral muscle, which kind of goes out like this. One thing we can do is we can just approximate it as a bunch of individual unipennate muscles going off like this, and maybe they individually have different pennation angles. But it turns out that is a pretty good approximation to the truth, which is maybe a more complicated thing, kind of like this or something else. So these are the 4 types of orientations of muscle fibers that you'll see in skeletal muscle. There's actually a few others that are not drawn here. There's some that like you see in the eyeball, and there's some that you see in like the intestinal muscles. But the ones that we're going to encounter are parallel fibered muscles, unipennate muscles, bipennate and multipennate. And with these more complicated ones, understand that one common trick that we're going to do is we're just going to take them and we're going to break them up into little individual unipennate muscles. So that is how we can start thinking about maybe the macroscopic structure of muscle.